Hello and welcome everyone. I'm your host Stefan Burns, geologist. We just had a magnitude 7.3 earthquake strike Mexico near the border of Guatemala. We can see it right here in the Chiapas region. Great coffee. But this was a big shaker with multiple aftershocks, as you can see. Here's our 7.3 at a depth of 18.6 kilometers. Quite shallow. A tsunami threat has been issued for this event, though at this point I think it's probably passed. This is occurring about 90 minutes ago, a little bit less than that. You see a 5.3 aftershock, 5.1, 6.0, 5.0, 5.1, 5.3. So a lot of activity from this magnitude 7.3. And this is almost in the exact location as a magnitude 8.2 megaquake that struck September 8th of 2017. And this is important for a few reasons. You will also recall that we just had a double sequence strike Venezuela on the 24th of June. So less than a month after that, we have this 7.3 strike here. And well, because that is almost the exact same location, it shows you how in less than 10 years, we can build up enough strain to release with a magnitude 7.3 earthquake. Now, an 8.2 is going to be about 32 times more energy. It's going to be a lot more energy released. This is about 3% the total energy of that 8.2, showing how that you can still get these magnitude 7s to build up. But from my quick peruse of some of the sources, there was shaking felt. It doesn't seem anything super destructive has occurred as a result of this magnitude 7.3. This is a developing story, so we don't have all the information, but it seems that in general, everything's okay. That again, we may find out that there's actually some damage that's been happening, landslides, things of that nature. Maybe the tsunami threat did materialize with a tsunami that came in, but I don't get that sense. We'll update as we go through this live stream. A lot to cover today. One of the big topics that we're going to be talking about is now, where does this go next? Because, and let's check this out. We can go to our Google Earth here, and we'll look at this quite a bit more. But if we look here at Google Earth, here's our 7.3 today. You see that this is in a subduction zone. Mexico gets a lot of earthquakes. Actually, Mexico is a very active place seismically. Case in point, that 8.2 occurring just, well, a few years back, actually a little bit more than a few years, but about 10 years back, and now this 7.3 following up. And we see that we have this doublet here in Venezuela that was extremely destructive because of how those two earthquakes struck. You have the 7.2 starting to shake everything up, and then 39 seconds later, 7.5 adds in and just creates this really destructive, longer duration earthquake sequence. Of course, there's also really bad construction practices for a lot of these locations around the fault trace. That's why a lot of buildings came down. There's still tens of thousands of people missing, about 5,000 confirmed dead, but it's the death toll, that was the 24th of June. It's now the 17th. You're not surviving under trapped rubble for 3 weeks. You're simply not. So the death toll is tens of thousands from that event, unfortunately. Thankfully, we're not going to be seeing that with this event. They had that 8.2 in the past, the 7.3. Thankfully, it's not near a super populated area. Some of the bigger cities did get some shaking, but nothing to necessarily be super concerned about. Though, again, we're going to check this out, make sure that's the case. But you'll see these other two earthquakes here. Magnitude 6.1 in the Gulf there, just to the northwest of Cuba on the 8th of June. That's an anomalous earthquake, the biggest ever to strike the Gulf. And here we have a magnitude 6 there that popped off after Venezuela on the 30th of June in the Gulf of California. So we had two Gulf earthquakes, which is interesting. And you notice how they form this really neat pattern here. The other thing to point out, we'll talk about it more, but this double sequence for Venezuela struck on the Bonoco fault. This is a right lateral transform boundary. The plates are slipping by. look at how less than a month later we get this 7.3, which is fairly equivalent in magnitude, mind you, to strike at the other key junction point for the Caribbean plate. Okay? So you get big movement here in the middle of the Caribbean plate, going like this, right? And then you have on the other side a balancing out with a reverse thrust earthquake where it pushes up. That's why they're worried about a tsunami. And well, we're going to go over a lot in this video. So hello and welcome everyone. I'm your host Stefan Burns. If you're new here, geologist, geophysicist, space weather guy. We cover a lot of things on the channel: earthquakes, solar activity, space weather, you name it, I cover it. We do things as soon as possible for big events, so I'm live as soon as I can, just like today. I think that's important, and to give my overview of the situation to the best of my ability. We look at things from a variety of perspectives, not just from one single perspective. We're open-minded. We want to understand things to the best of our ability because that's what matters when it comes to big Earth events and potentially, I mean, I'm not claiming that I'm saving lives, but there are certainly people who have watched my videos and had a big earthquake strike and they've been prepared. So, you know, we want to be as accurate as possible, and that requires looking at things from a variety of perspectives, not just one single perspective. So here it came in as a 7.4, but USGS has it as a 7.3 with further review of the data. Anyways, 7.3, 7.4 doesn't make too much of a difference there. And this caused a tsunami threat, but it doesn't seem to really have manifested with a tsunami, though it's still active. I just refreshed it, as you saw, it's still active. And we can read here this notice. So 7.3, now they have the new magnitude there. Earthquake, tsunami waves have been observed. Okay. Hazardous tsunami waves are forecast for some coast. Tsunami waves reaching 0.3 to 1 meters above the tide level are possible for some coasts of Guatemala and Mexico. Tsunami waves less than 0.3 meters, that'd be 1 foot or less, above the tide level are possible for Colombia, Costa Rica, Ecuador, El Salvador, Honduras, Nicaragua, Panama, and Peru. So a lot of Central America, which is close by. Actual amplitudes at the coast may vary from forecast amplitudes due to uncertainties in the forecast and local features. In particular, maximum tsunami amplitudes on atolls and at locations with fringing or barrier reefs will likely be much smaller than the forecast indicates. So it looks like this tsunami forecast is really just for Central America and Mexico, not really reaching up into North America. And it doesn't seem to be that significant, though waves are powerful. So just in general, when you get strong wave action, you don't need much to get swept off your feet. And then the way tsunamis roll in, it's not just like one wave coming in, that's it. It's kind of this continuous push. So it can damage harbors and boats that are moored. It can bang them up. It can be problematic. So this is definitely something to be mindful of. You want to get off the beaches when you have a big earthquake like this, regardless of whether there actually is some strong effect from it afterwards or not. You just want to get off the beaches. So that is what's happening. Let's look at our 7.3 here with our overview from the USGS. So here we see the did you feel it in the shaking intensity? So we'll put on our plates, our faults, and we can even look at the historic seismicity just for a moment. Look at how many earthquakes occur in this area, right? A huge amount. You'll notice that they're shallower there as you get close to the subduction trench, and then they get deeper further in. That's how this works. The plate goes down, subducts. That's how we know plate tectonics is a thing, because we see this distribution of earthquakes at different depths further away from these very obvious bathymetric geologic features, these subduction trenches. And we see that actually this area specifically, look at these circles there, that's indicative of the size of the earthquake, the magnitude. You see there's quite a lot of big circles right in this area. So this is close to that 8.2 that occurred. Even up here, you see a whole bunch of big circles as well. So Mexico is very active, as you can tell. This subduction trench is very active for the Cocos Plate. And then we see our seismicity going up here, the Gulf of California, and then here you have California. Look at how much it drops off. It's interesting. You get this big drop off there, transform junction with the San Andreas and all the other strike slip faults that also weave through California, Walker Lane, shear zone, Nevada seismic zone, East California shear zone. There's a lot of different junctions that this energy then spreads out across North America. So then you get back up to the Juan de Fuca plate. You get big earthquakes here up to magnitude 9. We saw that in the year 1700, and then we start to go to the northern part of North America where you get up to magnitude 9s as well. So we've been seeing a lot of activity here to the south. Not only does this mean that we could get activity going north, we could also see enhanced activity going to the south. I do think we're kind of due for a bigger earthquake to strike Chile, or maybe it's Peru, Chile, somewhere in this subduction trench. We haven't had one for a couple of years. We did have a 6.9 that struck Antofagasta recently, but 6.9 isn't really equivalent to a mid-7 or even 8. So I do think also this has implications for further south, but I think there's more direct implications for going to the north. And that's why we're really looking at California very closely, because there's a few lines of evidence supporting that. So that is the seismicity. We go to did you feel it, and we can look at our responses here. We've had 156 responses thus far for this earthquake, so not too many. And if we look at our intensity, basically people were feeling light to kind of, shaking, so moderate to strong shaking in this area. Maybe we can get a better, if we go back to our interactive map, maybe we'll get a better feel here if we look at our did you feel 1 kilometer responses. Now a lot of people, the Mexicans living here, or the Guatemalans just to the southeast, they might not know about the USGS service and did you feel it and the reporting for that. So keep that in mind. So actually we'll put on our 10 kilometer ones, and we see just only a few responses here. But this one is showing a 6, and that is strong shaking. And these others are more like light shaking. So it's distributed outwards. But the shaking would have been strongest right near the coast, close to the epicenter. So Mazatlan, I guess, this area here would have felt it, but you notice it's really just rural areas, some small towns. Thankfully, no really big cities. That would be bad. A 7.3, for example, let's say we had the 7.3, but it was directly under Mexico City. That would not be good. That would be very bad. We see some people did feel in Mexico City, but at this point it was very light shaking. Just a few people probably felt that. Fairly early in the morning too, occurring around just before 8 a.m. in the morning or so. So that is the deal with the shaking. It's just really, as I see it, more of a progression of seismic energy moving northward. This is kind of what I'm worried about. Here we can see a video of the shaking. So some of the shaking also landslide. So this triggered a landslide. We're getting some video now coming in. And you can do a search on X for Mexico earthquake and some things will pop up. But we're not getting too much and nothing looks too severe at this moment in time. But this is one of the risks of big earthquakes. It's not just building shaking and things like that. It also sets off other geologic processes. So erosion, right? One of the biggest geologic processes, which is just erosion. Big earthquake sweeps through, right? The seismic waves, and well, you can get rock slides and you can get just landslides and more. So this probably set off quite a few of these, this being one example. Hopefully it didn't cause too much damage. And hopefully there's no communities in that area that maybe are perched right upon like a cliff. There's plenty of examples around the world of large communities, hundreds of homes right around like a cliff face, and you know, that whole thing could come down. So I don't think anything like that's happened, but we really don't know. This is so recent that we're still getting information about this. But if we type in Mexico earthquake, let's see what else comes up as it relates to some of the shaking here. Here's a video showing some of the shaking that occurred. 7.3 again. So pretty big. Thankfully not bigger. Could have been worse if it was bigger. But it was only a 7.3, which is good. This does come one day after, like less than 24 hours after the U.S. Navy set off this experimental explosion off the coast of Florida, which is interesting. So, you know, I'm not saying the two are connected other than the time, but often we do see weird things happening all at the same time, like this clustering of events. We've just had huge flooding in Texas. I think it's Kerr County with the Guadalupe River, even more so than last year with that historic flood that swept away Camp Mystic. The Guadalupe River rose up even faster this time. So there's been big flooding events to the north. Of course, we've been having these crazy heat domes in North America. There's wildfires in Canada. We just seem to get these geo events to cluster in time for some reason. So pretty significant here, this earthquake now, and really speaking to what could be coming next for North America. Not necessarily just for California, though that would be the top spot. It could also be bigger activity to the east of California. It's not guaranteed, but we'll look at the history. There's a bit of a history with this. Specifically with the 8.2 that struck Mexico in 2017, we had Ridgecrest 7.1 strike California 2 years later. So that's one example of this. So here we see some of the shaking. Yeah, so, and I want to show you too, before we get to that story, which I've touched on, but let's look at this. Let's compare the magnitudes, 7.3 to 8.2. So a magnitude 8.2 is about 8 times stronger than a magnitude 7.3 in amplitude. So this is like the height of the wave, right? And 22 times stronger in terms of energy released. Okay, so it's 22 times. I was thinking it's like more like 30, but it's 22 times stronger in terms of energy release, this 8.2 versus this 7.3. But it goes to show you that in about 10 years after a megaquake in 8.2, there's enough energy built up to cause a 7.3. And that's the thing. Why did the 7.3 pop off, right? If there was just this magnitude 8.2 right here, we just had that magnitude 8.2. Why would a 7.3 pop off so soon? There's really no reason for it to need to release so quickly unless there was some other, I mean, there's multiple possibilities here. But unless there was some other trigger acting upon this, a big plate shift that occurs that doesn't occur that often, which then cause a corresponding release of energy from this key junction, well, I think that would explain it. And that's Venezuela. Last time we saw a doublet like this was in 1812. Way back, 1812. This is basically equivalent to the 1812 Caracas earthquake. Actually, that was a 7.1 and 7.4. Some estimates have it as a single 7.7 earthquake, but it seems the consensus that there's 2 earthquakes, 7.1, 7.4. This is 7.2, 7.5. Most destructive earthquake to strike Venezuela ever. Because again, there's tens of thousands of people that are still missing, and it's been like almost a month now. So it's bad. It's really bad. So you get this earthquake right at this key junction there, and that's going to the right. You know, it's going like this, right lateral. And then you get up here now, this 7.3. Right the site where you had an 8.2 prior, almost effectively right on it. I mean, if we measure, it's not going to be that far. 114 kilometers away, so no big deal. I mean, that's basically right on top of it. And as I showed in a prior video, I think I already have it activated, yeah. as I showed in a prior video, we had this 8.2 up here in Alaska, equivalent magnitude to the 8.2 from Mexico on the 29th of July. So all this month. And if we measure between the two, let's measure between the two epicenters, we get exactly 7,000 kilometers, which is kind of interesting. But importantly, you'll notice it slices directly through the shear zone of the basin and range, right through that shear zone to the east of California. And in fact, if we go one step further, we can turn on our magnitude 9 megaquake that struck Cascadia in 1700. Look at how that epicenter is exactly on that alignment. So this to me is indicative of the fact that these are key tectonic nodal points. And we know that's the case here because we see this, this big transform junction terminating right at the subduction zone where we've had now 2 of these earthquakes, okay? But then Alaska up here, very, very, very active, that 8.2 being equivalent to Mexico. It's only 4 years later, mind you. It's actually just a little bit less than 4 years later. So very close in time geologically, right? In the human time scale, you'd be like, oh, they're not connected. Geologically, it's like, hey, they're like right after one another, and they're the same magnitude, equivalent energy release. You see here, California, just off to the west. So this energy propagates up like this. Let me show you that. We'll look at 2 different views here. Here we have the 8.2 in Mexico. I don't have a visualization yet for the 7.3 that just struck, but since it's almost the exact same epicenter, you get the idea. Look at the seismic waves not only sweep across North America, but in fact they travel across the entire globe, right? These are big earthquakes. I mean, the 8.2 especially is a big earthquake. Here's the antipode there, Indian Ocean, and then it'll propagate around multiple times. This is not just a one-off, it kind of dissipates after one circumnavigation of the globe. It builds up and comes back and just keeps sweeping around 3, 4, 5 times. The biggest earthquakes can cause the earth to reverberate for hours afterwards. Here we see our time, okay? So that's the 8.2 Mexico. Here we see it again, this time though static. Look at how that energy sweeps across. Now what we see with earthquakes is that there is this triggering effect. You often have these sequences that occur where you get a big earthquake and then not too long afterwards, close by, you get another earthquake. Sometimes it's equivalent magnitude, often it's less. Usually, more often it's a bit less than that initial sequence. But Venezuela, Mexico is a fantastic example of this. We had the 7.5, 7.2, and then less than a month later, 7.3 right there. That's super close by, okay? Overall, just showing that there's a lot of seismicity right now with the Caribbean plate, which is the thing that connects. That and the Caribbean and the Cocos plate are what connect North America and South America together, okay? So now we get the 7.3. We've also had a 6.1 there, Cuba, 6.0 there in the Gulf. Let me show you that. But this energy has been propagating up. After this 8.2, we had Ridgecrest in 2019. So this is September 8th of 2017. We had Ridgecrest in 2019, not too long afterwards. Specifically, Ridgecrest was on the 6th of July. So look at how July has been super, super active. The megaquake that we just had last year, the 8.8, was also in July. And specifically, in fact, it was July 29th, the same day as this 8.2 right there, right? July 29th. So 4 years later, exactly on the dot, we had the 8.8 strike Kamchatka. Last time we had a big earthquake strike Kamchatka was 1952, magnitude 9. Guess what? 1952, we also saw this magnitude 7.5 here, Kern County. That's the last big magnitude 7.5 or greater earthquake that California has had. Ridgecrest was a 7.1, okay? We had this 7.1 here in 1999, 7.3 there in 1992. There was the 94 Northridge, that wasn't a magnitude 7, that was in the magnitude 6 range. 89 Loma Prieta was less than magnitude 7, is this magnitude 6.9. So the last big magnitude 7.5 plus in California was in 1952, the same year that there was a megaquake magnitude 9 in Kamchatka. Last year we had an 8.8, that was the next follow-up to that. And we also, as you see here, had big activity in 1812 with the 7.5 and 7.1 back to back within 2 weeks. See that? 1812 December. And that is following up 6 months after we had a big earthquake here, Caracas, in 1812. So we see that 2 times with big earthquake activity in other parts of the globe, we've had big activity in California correspondingly. And while history doesn't repeat, it rhymes, it's rhyming now across both of those events, which is very interesting. So now we see this follow-up with this 7.3 after this 7.2 and 7.5 in Venezuela. And then we also get the 6.1 here in the Gulf and the 6.0 there in the other Gulf. Let's check out the first one, Cuba, right here. We see the seismic energy there propagating out. So the point that I'm making is that all these earthquakes across different magnitudes, of course the 7.3 Mexico is a lot stronger than 6.1 there, but this is a novel location for that earthquake energy to go out. Not only is it loading up Mexico, Cuba and Jamaica and all these other places, it's sweeping down like this. It's spreading out all directions. It's also loading up New Madrid, right? There's old buried fault systems in there that can accommodate a magnitude 8. Imagine a magnitude 8 hits under the Mississippi. It's all just sediment there, right? It's going to shake like a son of a bitch, okay? It's not going to be good. That's what happened in 1811, 1812. But this seismic energy there propagating out, that's from the earthquake that struck Cuba. That specifically was on the 8th of June, so not that long ago, just a little bit more than a month ago. Here we see the 30th of June, and we see that that's coming a little bit closer to California, propagating upwards like this, but also going out like that, of course, going to the south as well. So there has been a lot of activity nearby. And as this continues, I mean, already based off of Venezuela and these 2 Gulf quakes, and then also some of the seismicity we've seen in California recently, I've already been, worried about California. Now with the 7.3, it's only strengthening that argument. Does not mean something's guaranteed, but it's not looking all too hot right now. Case in point, a little bit more evidence for this is if you go back to our Google Earth here, the same day as Venezuela, and also an earthquake in Japan, 7.2, same day, 24th of June. Just a few hours before Venezuela, we had a 5.6 pop off here, Ukiah Willits in Redwood Valley, a location that's never had an earthquake this big, at least in our historic record. So this was very notable. And this is occurring in a junction right there where you get this line of historic earthquakes, and in general to the south and to the north you get less seismicity, like basically nothing in these coastal ranges, but you get this line right at the bend in the San Andreas, a key strain accumulation point. You had that pop off. So that's already showing this connection between California and Venezuela. You also have 1812, and well, now we're seeing the seismicity move closer in, and we also had that 8.2 here, and then Ridgecrest less than 2 years later. So I think now we are going to be seeing a big move in California, or perhaps like Arizona, Mexico. I mean, that's much less likely. I think it's most likely California, but within the next couple of years, I think it could happen this year. I think it could happen very, very soon. But geologically, the next couple of years are really prime time for that to pop off. And we do see this connection between solar activity and earthquake activity. So let me show you this graphic, because this is quite interesting. Here we have our, not only our sunspot activity, our sunspot cycles. I'm going to turn myself off, so watch my cursor, okay? Oh, yeah. So not only do we have our solar activity and our solar cycles via sunspots, we also have the polar field strength of the sun laid over here, showing that this is a larger solar cycle that we're going through. And this data goes up to the 29th of May, but we're only plotting earthquakes magnitude 8 or greater here. So this is still up to date effectively. We're missing like 1 month of sunspot data. It doesn't really matter. And we see our scale range there, magnitude 8, 8.5, 9. You see our most active years here, the 9.1 Sumatra, 9.1 Japan, 8.6, 8.2 there in 2012. And then we see here this magnitude 8 that struck Kamchatka, 2025. we see that solar cycle 25 has been stronger than 24, but weaker than 23, 22, or 21. And we see these solar maximum periods outlined here in, what was that, like a light yellow color, kind of like a light yellow. So here's our maximum period. We see sunspots are highest during maximum. So there it is, there it is, there it is, right? We see really how weak solar cycle 24 was. You notice for the polar field strength, this is the upper part of the sun. So the top and the bottom of the sun, just like Earth has its poles, right? The sun has its poles. And during solar minimum is when that polar field strength is the highest. It kind of goes away, actually. It goes to 0 during solar maximum because you have the flip of the magnetic field. But during solar max, you can see it's right near that 0 line, or it's transitioning. We had the polar field strength quite strong back here before solar cycle 21 maximum at a strength of 1 Gauss. Down here, it was a little bit more than 1 Gauss. And then you go up, it's still 1 Gauss. And then look at how it collapsed after solar cycle 23 maximum, only going to 0.5 Gauss. And then solar cycle 24 maximum, there again transitioning through 0, also still weak. We don't know how it's going to line up for solar cycle 25 minimum going into solar cycle 26. But we do see the polar field strength of the sun has been decreasing going all the way back to 1975. This data going all the way back to 1975. Well, look at our earthquake activity. Here we're finally getting to our earthquake activity, all right, these red lines. Look at how there's been such a huge increase in our earthquake activity when the sunspots and the polar field strength have gone down for this longer term cycle known as a Gleisberg cycle. It's like 80 to 100 years in length, okay? And keep in mind, because this is obvious to me, but not everyone knows this, and you know, there's a lack of education on this somehow, some way. I really don't understand. But all the energy coming into the earth, almost all of it, like 99.9999, is from the sun. 1,362 watts per square meter on average coming in from the sun. So that means you take a 1 square meter of the earth, right? And you'll get 1,362 watts on that guy, okay? Now, if you know solar panels, you know, a solar panel that's bigger than 1 square meter will get you maybe like 400 watts because they don't have 100% efficiency. But if you know, like 400 watts is actually a good amount. If you have 400 watts coming in, that could run basically 4 refrigerators to give you a sense of scale, or like a 1 dehumidifier, or things of this nature, like 4 fridges. That's quite a lot. So that's a huge amount of energy coming in every single second from the sun. And what determines the energy of our planet is A, that incoming energy from the sun, and then B, how it's modified. How much is stored and trapped, how much is released. You also have the dynamic of, well, the sun's been shining for billions of years, and so we've had a lot of that solar energy sequestered geologically in hydrocarbons, right? Fossil fuels. You take millions of years of solar sunlight sequestration into very energy dense hydrocarbons, and you light that match and you get the kaboom. That energy now is being pumped out into the earth, and not all of it radiates outwards. You have a lot of that energy get absorbed into the oceans. You have a lot of that energy now bouncing around in the atmosphere. You have an energy imbalance. So fundamentally, the energy for the earth, almost all of it, like by far, you have just a tiny, ultra tiny cosmic component, of course, because there's other stars out there and whatever. And you have some radioactive decay in the earth itself, which is not negligible, but really not really relevant to our discussion here. It's all from the sun. Everything else is modifying that solar energy input. So of course the sun is important. Geologically, geophysically, weather, climate, biologically, of course, right? It goes without saying, but not everyone's educated on this, and that's fine. That's one of the things that I do here on the channel, okay? So we see that when we have these weak solar cycles and the polar field strength goes down here, look at all the earthquakes that popped off. It really started up at the descending phase of solar cycle 23 and then really continued to stay active through solar maximum for solar cycle 24 here. And it stayed active. We've had a bit of a gap here with solar cycle 25 with this strong ascending phase right there, but we have had this 8.8. I think it's very, very likely almost guaranteed that as we go down in our solar cycle, we are going to get a lot of megaquakes. Typically, we get one per year. That's the average. We had 4 years from 2021 to 2025 where we didn't have any magnitude 8.0 or greater earthquakes. The last one before this megaquake in Kamchatka was August of 2021. So it's been a while. Then we have this one of the strongest on record, right? You have the 9.1 Japan, 2011. You have the 9.0, 9.1, it's somewhere in that zone, Sumatra quake, 2004. And then you have 1964 Alaska, 9.2. You have 1960, 9.5 Chile. And then you go back to 1952 at 9.0 Kamchatka. So that's our category for the recent record where we have seismographs to collect the data, one of the strongest on records. There's been other big quakes though, of course. But we are very likely to get a lot of earthquakes during this time period because of just these larger forces and factors that are at play. So we've had now the seismic energy come up. We can track the movement of it here with this map that I made recently. Here's that 8.2 that struck in 2017. You'll notice how there is this progression through magnitude 7s going forward, right? There in 2020, 7.4. You actually had just 10 days afterwards, or 11 days, 11, 12 days afterwards, this 7.1 there. So we could also get a follow-up in Mexico. That's quite big. But this is a mega quake. The 7.3 is unlikely to trigger another magnitude 7 immediately adjacent, but it could be a high magnitude 6. But we see this progression there. Here's 2021. Here's 2022. We even see beforehand we had the sequence of magnitude 7s there in 2012 and 2014. So all very closely spaced together in 2012. We also get this one in 2014 there, but the cumulative magnitude between these three, 7.78, that preceded that by about 5 years. And then we see now that thread going from the megaquake kind of petering off. Now we have the 7.3. You do see though, again, here, ridge crest, and look at how it also triggered seismicity nearby, or at least you can make that claim, or you could argue that point rather. So there, the 6th of July, 2019, 7.1, big shaker, and then a quick double burst right here. Equivalent magnitude, that's another thing, you have to look at patterns and trends. These aren't wildly different in their magnitudes. This isn't a 5.7 and a 6.5, they're both 6.5 occurring less than 2 months apart, just less than a year after the 7.1. So yeah, showing that this strain dynamic and the stress release is happening for a larger zone geologically and that they're connected. We've recently had the 7.0 here at the triple point in December of 2024. And so we've had these up here, 2018, magnitude 6.8, 6.5, 6.6, all in the same day, equivalent to magnitude 7. Here you have a 6.5 that popped off just a couple months before the magnitude 7 triple point down below here, showing the Juan de Fuca plate made a big move in 2024, equivalent. So everything's locked and loaded and ready to go. Now, we've had this 7.1 there, the ridge crest, that loaded a ton of energy onto the Garlock fault. So let's give that a look. Let's give the Garlock fault a look because we've had some of that recent activity there. And we can get it by looking at our most recent earthquakes here, but we're gonna have to change this to 2.5 plus. Here we go. You'll notice, and we're also gonna put on our US faults. Okay, and largest magnitude. So here's our 5.6 that struck Willits, Ukiah. That again is a historic earthquake, very important. You also had a 4.4 strike Covello to the north shortly afterwards, about 2 weeks afterwards, not that long ago, on the 11th of July. But besides that, the biggest earthquakes are these two here on the Garlock fault. So here we have the 7.1 Fraser Park, and here we see the next day on the 13th, the 7.3, both of them having earthquake swarms. If we go to all magnitudes, you'll see these earthquake swarms, right? Here we have 194 earthquakes. After this Johannesburg 4.3, big release of energy. Then if you go to Fraser Park here, not as big of a swarm, about 21 events there spread out. If you go a little further north, 23. even 24, but still a big event. And in fact, I can show you this 3D fault viewer here, which is interesting. Because the Southern California Seismic Network has said that this 7.1 in Fraser Park was on the Plato Fault, which we can see right here. So here's the Plato Hills, and here's the Plato Fault, okay? Now, keep in mind the epicenter is like right here. So at first glance, they're pretty far apart. But let's zoom out, and let's click the San Andreas here. Well, that's the Garlock Fault. Let's click the San Andreas. Let's also click here the Lockwood Valley Fault, and then also the Big Pine Fault. And we're going to map these in 3D. So plot them in 3D. This is pretty cool. And you'll see now how the Garlock Fault and the San Andreas Fault are pretty steep in their dip. They're almost vertical, all right? Now here's the Plato Fault. It's also dipping like this. And then you see the Lockwood Fault and the Big Pine Fault right there. So the fact that we had that follow-up to the magnitude 4.1 Fraser Park, the next day in Johannesburg, right where the Garlock Fault has this section where it has a discontinuity, a little jump, right? Shows you that there was something that occurred with this part of the Garlock Fault there. It doesn't mean there was a huge rupture, like a big, like multi-meter slip event. It's only magnitude 4.1, 4.3. But you have to look at the spacing, the timing of these things. And it tells a story too, also the dynamics of the earthquake. So we'll come back to this. Let's go back here. Let's look at our 4.1. And let's look at our moment tensor for this. And you see that our moment tensor has two solutions. One is vertical here, basically. The strike is 14 degrees. So effectively, the fault is like north-south, all right? And we see that it has a rake of 39, which means that's thrusting upwards, but also it is still some strike-slip component. Well, the other fault solution here is 260 degrees, okay? That's the strike. So it's not exactly 270. It's a little bit inclined from that. And you see that the fault plane on that's 59 degrees, the rake is 139. So it also has a thrusting component. If this rake is positive, it means that there's a bit of upward momentum with it. So it's a reverse thrust, but there's also a strike slip component, because for that to be perfect thrust upward with no strike slip, it needs to be 90, just straight 90. We don't have that. So it's in between 90 and 180. So it's an oblique thrust where you have strike slip and it's also thrusting up, okay? Well, if we go back here and zoom out, you'll see that the Garlock Fault doesn't have that strike that the earthquake has. 270s here, 260s like that. So it's close, but it's not exactly on it. San Andreas has a strike that's more like 280, 290, okay? See that? And well, it actually may be the other 180 opposite, but you get the point. So we see that though, if you were to balance these two out, and also with these other faults here, Big Pine, Lockwood, if you were to balance out these strikes, they basically end up being 270. And the thing is, when you have all these faults meeting at a junction, it's not like they're all discontiguous and not connected. They're all connected together. They form, a larger fracture zone and fault zone that then connects them all and like intersplices them together, just like some really cool rope weaving you can imagine, or braiding of your hair, right? You can take the different strands and braid them together. That's what faults do. Everything's fractal in the universe. This is no surprise to anyone that has a few brain cells. So the fact that that was at a 260 strike shows that, that's probably not just the Plato fault, which they're showing here, right? It's really a combination of these faults all together. And it was this thrusting motion. So you had a bit of a thrust up here. So clearly a bit of a block movement. Now, if we go back to our latest earthquakes, here again is that splice location. And look at how right at the end of the termination for this western section of the Garlock Fault, you get this 7.3. Well, guess what? It's an extensional earthquake. If we look at the moment tensor here, we see that the the rake is negative and close to negative 90. So there's a little bit of oblique component like strike slip, but very little. Basically, it's mostly an extensional earthquake where the rocks pulled apart, just like this, and you had a block that goes down as a result. But you have this pulling apart motion. So how perfect is it that you get this thrusting motion over there, and then a day later, you get them to pull apart right at where you get the fault junction to have this weird splicing and disconnect, right? It's literally right at the end of that trace. That's not something that you'd expect from the Pluto fault, right? If this was 100% just on the Pluto fault, you probably wouldn't get that to occur. Roughly equivalent in magnitude, 4.1, 4.3, right? These are connected together. So this is showing that this is what I would say, okay? Everyone can make up their own interpretations, and I'm sure there's a few ways to skin the cat, but I think that's a pretty clear slam dunk scenario. We just did get this significant movement of this region by the Garlock fault right around the same time as the 5.6, Venezuela, now Mexico, the magnitude 6 in the Gulf, and also the 6.1 in the other Gulf. So there's a lot happening. There's a lot happening. There's a lot happening. And well, things are looking pretty hot further north. But the 7.3 is the big story for today. We can see here our largest quakes. We have now had multiple aftershocks. So our 7.3, 6.0 aftershock, 5.3, 5.1, 5.1, 5.1, 5.0, 5.0. Big release of energy, even like a 4, that's a 5.0 there, a 4.4 there, though that was earlier. This was also earlier, you may recall that was on the 14th, so that was a bit of a foreshock there, that 5.0. Not exactly on the epicenter location, but pretty bang on. Interesting, we were actually talking about that with the last live stream. So let's see if they've updated the tsunami threat right here on the NOAA website. Okay, good. No tsunami warning, advisory, watch, or threat in effect for the magnitude 7.3. It looks like they've lifted that. If we go here, and the tsunami threat from this earthquake has now passed based on all available data. So that is good news. That is good news. I'm not sure we're going to get any new video on this, but let's just give it a search. We'll go to latest here. I'll finish off my coffee. Some shaking here. This is southern Mexico, I guess. There's a lot of posts about the earthquake, but not too many video. Here's some video. You can see the windows flexing with this. This is the one that shows the building. This is kind of wild. You see the building really swaying like that. Don't know where this specific video is from, but not from right on the epicenter, of course, or even that close by, but still some pretty big, long period shaking. That's actually important. Let me show you two more things. I have we did just have king tides. So let me show you the king tides that we've had recently. No surprise. Uh-oh. I don't know if I can rotate that somehow. I think I can probably, that should do it, I think. Yeah. Okay, so this is taken by my friend Michael here. This is what we're looking at is San Diego. This is Mission Beach. And during king tides, where the tides are very strong because of the, when you have the moon in its supermoon position, whether for a full moon or a new moon, you get king tides where they're stronger than normal because the moon is simply closer to the earth. It's about 1/8 closer to the earth than average. So you get the water level go up. That's also stronger earth tides, vertical displacement of the earth and fracturing of the earth. So you see Mission Bay right there. and it raises up over the area where you can walk and then floods down into a storm drain, which then flows out to the Pacific. So this happens like every king tide, which they're not that often, but that was back, king tides, the new moon was on the 14th of July. So here we are the 17th, just a few days after, and boom, 7.3 hits Mexico. And well, we also had the Venezuela earthquakes occur pretty close to these king tides because it happens for a sequence of a few new moons, at least this time. Right now it's new moons. So we've had that. And then we can also look at just how seismic energy propagates. So let me show you the different types of waves. Our seismic wave video here. So you're going to first feel that P wave. That's going to be what strikes. It gives you a jolt. If it's strong enough, you'll feel it. If not, then this is what sets off the early warning networks. That gives you 5-10 seconds, maybe more. It depends on your proximity to the epicenter. Then you get shear waves to come in. These are more destructive. This is where things really start to get shaking. So you have to be, hopefully it's not a super big one, because these can really start to get things going and can cause problems, knock you off your feet like we saw in Venezuela or multiple other instances. And then you get surface waves to roll through. So with that video that I showed, the building swaying, that's the surface waves rolling through. You get 70% of the energy in an earthquake contained in surface waves. You not only have love waves, which are horizontal surface waves, and you get this shaking motion horizontally, primarily in the surface. See how that bottom layer is unaffected? These are primarily in the surface of the crust. You also get these Rayleigh waves, which have this rolling motion, this jerky rolling motion, and that can be really strong, and they'll last for a long time. It's really shaking the area. If you have a basin, right? You have natural geologic feature of a basin, and you have sedimentary fill, it can bounce around in that basin and prolong the shaking because it's reverberating. There's a resonance that develops. That happened with the magnitude 6.0 that struck Napa in 2014. It's a natural basin, a volcanic basin, and you got tons of shaking there because you have the sedimentary deposits from the Napa River that have been laid down. You have many places like this. LA Basin is another example of where that could occur. That's why people are worried about a big earthquake around Los Angeles because, well, that could happen. And those surface waves, they travel for a long time. They circumnavigate the globe. So these are different types of seismic waves. The P wave is your early warning if you feel it. But for like, let's say a magnitude 5, if you're not immediately on the epicenter, like what happened in San Diego last year, a magnitude 5.2 struck, I felt that. It was just a single jolt to my apartment. Just boom, it's like, whoa, what happened? But there was no feeling the P wave or the S wave. It was just the surface waves that we felt. But these are the very destructive ones. The other thing to mention here is that every earthquake has its own frequency spectra to it. So is this Rayleigh wave a 1 hertz rolling motion, like 1, 2, 3, or is it faster, like a 3 hertz rolling motion? Well, depending on the resonance of a structure, everything has a resonance. So if a building has a 3 hertz resonance where it starts to amplify like this with 3 hertz, and it's shaking for long enough, that's what can cause a building to collapse because it enters into resonance with the earthquake waves and then it drops down. So the ground has a resonance. If the ground has a 3 hertz resonance and the earthquake releases a lot of 3 hertz energy and then the building also has a 3 hertz resonance, you're in for really bad time. So these are just some of the dynamics that exist in general with earthquakes. So I think that covers it as it relates to what's happening with this. But I'm sure we'll have some questions. We got a lot of people watching the live stream right now. So hello and welcome everyone. If you're new here, I'm your host, Stefan Burns, geologist, geophysicist, space weather guy. Here to help you understand what's happening on this planet energetically. And we have a super thanks here from our mod, Dan. Thank you, Dan, so much for the super thanks. Also one here from Amanda. Thank you so much. If you have a question that you want answered right now in the live stream, please attach it to a super sticker or a super thanks. I have a separate list that pops up, which I can look at. Doesn't matter when you post it, I'll be able to find it and comment. I will take some questions from the general chat, but that's going to be super random and just basically luck of the draw. So if you want your question answered, you have to put on a super thanks. Basically, it's just how the way it works. But I will also take some general questions now at this moment in time. But we'll start here because we have just a few to go through. We also had this water main break in Los Angeles recently. If you didn't hear about that, a 100-year-old giant water main broke in West Hollywood. And it opened up a sinkhole. Do you think recent earthquake activity had anything to do with this and the flooding that happened? I don't think so, because if it was the case, it probably would have been the fact that there was an earthquake right at the epicenter and then the main broke. If it's 100 years old, these pipes are old. They are very old. So it's just sometimes a matter of time. It gets rusted out, and then you get even just like a small hole, because they're under such tremendous pressure, can cause that thing to blow out. That's the thing. I used to work with utilities, and I saw a lot of things like this, sinkholes from water main breaks and more. And you just need one small failure to really propagate and then cause the whole thing to go down. And the water volume and pressure. This is a big water main, huge. I don't know the diameter on it, but it was clearly big because it flooded huge amounts of the West Hollywood area, and I think like the campus, the university campus nearby. So it didn't need much to get going, basically. So thank you for your super thanks. And Nirka, thank you for your super thanks. Big supporter of the channel. Thank you so much. And Seek the Light McDonald, thank you for your super sticker. That's much appreciated. Get over to our main chat to see, are we cooked? Hopefully not. What we would hope for, if there is something coming further north, which I think is the case, or further south too. Like South America is also, right, that Peru-Chile subduction trench is also looking like it's in the line of fire. If we are getting something, let's say in California, we hope it pops off to the east where there's not that many people. The thing is, you get this alternation in California. And let me show you the map again. We'll go back to my California big one map here, turn on the 7s so we can really see this. We have this 30-year periodicity. It's like 30 to 40-year periodicity where we get a lot of activity and then things go quiet, then we get a lot of activity again. You'll notice that with 1989, Loma Prieta, 1994, Northridge, and then we see all these earthquakes here that popped off. 1999, 7.1, 1992, 7.3, okay? You go back 30 years from the 80s and 90s, well, you get 1952, okay? So there's this 35-year periodicity. The most recent big one is 7.1 Ridgecrest. The other thing in addition to that, which basically showing that we're right now in that peak period for California earthquakes. In addition to that, you get this alternation between them being in the east, in the Mojave, east of the San Andreas, and then going to the west. So recently we've been having tons of activity here in the east. Eventually it will flip back to the San Andreas and to the west. Are we at that point right now? That's a good question. But we're probably close. Every day takes us a bit closer to when the earthquake activity will eventually shift to the west. So the next big one in California may be like Ridgecrest, where it's over here somewhere, right? Could also be Northern California. But it very well could be the first one that then shifts back over, and we could get a really big one on the San Andreas directly, like a Fort Tejon earthquake right there, right? Fort Tejon's down here, epicenter's there. They call it that because that's the only place basically that felt the shaking other than the natives with their tents and their lodges. But that was a huge rupture going all the way through that kink down into SoCal. So it was able to rupture the entire fault. Same with the 1906 San Francisco earthquake. It ruptured from down here all the way up to Eureka, past that junction. The really big magnitude 7.5 plus earthquakes are able to rupture past these stuck bends where strain really accumulates in the San Andreas. And that's why they are so big. Because they have that kink in them, they don't rupture as often, but they build up more energy. The other thing to be mindful of is that you could get a simultaneous rupture. There's more research coming out talking about that, about how with a potential Cascadia event, you could also get the San Andreas rupture, or perhaps the San Andreas ruptures, and that then triggers Cascadia. So these are all real dynamics that exist. They're just rare. On the human time scale, they don't happen that often, thank God. The geologic time scale is just another punch card in the slot, okay? Because the 300-year reoccurrence interval geologically is nothing. We're talking millions of years for the evolution of plate tectonics in these areas. But for us, it has very significant consequences. I mean, it is technically possible that there could be a simultaneous rupture of the entire San Andreas. Now, I'm not saying that's what's going to happen. It is technically possible. You have this Parkfield section in between, which releases its energy slowly. It's a creeping section of the fault. Sometimes, though, it does get stuck up. In general, it's slipping about 1 inch per year. It can go up to 4 inches per year. At its fastest, it can go down to 0 and get stuck. So you could technically get the entire San Andreas to rupture. So 1906 ruptured this section, 1857 ruptured this section. Down here to the east of San Diego is the section that ruptured last, or the furthest back. We haven't had a big rupture in this part of the San Andreas for a long time. Now you did have this 7.2 that popped off 2010. You see the 7.3 there, 1892. So these are close to the San Andreas, right? All connected in. You did have that, but specifically this section here, right? North of the Salton Sea, that's south of the Salton Sea. You see that fault discontinuity a little bit as well, okay? So this part's probably good. Here though, this section has been 200 plus years. Been a long time. This is the approximate location for the 7.4 that hit 1800 on the 22nd of November. So you have the San Jacinto fault cutting down. I mean, there's a lot of big faults that haven't ruptured. But we're really looking to the San Andreas and to the west probably, I think, though it could be to the east. Garlock fault super overdue. We see the Garlock fault right there. It hasn't had a big rupture in hundreds of years. Tons of energy loaded onto the Garlock fault from the 2019 ridge crest. So geologically be very elegant for that 2019 ridge crest that popped off, and then less than 10 years later, a similar magnitude 7 plus to hit the Garlock fault. Maybe it's a magnitude 6.7 that strikes Garlock, and then you get a 7 plus on the San Andreas. All these scenarios are possible, and then you get aftershocks. You very likely get, if you get some magnitude 7 plus hit the San Andreas, you're going to get magnitude 6 aftershocks somewhere. So maybe this location up here doesn't really feel too much from a magnitude 7 down there, but then they get hit with a 6.3. That can be very destructive. So these are all different scenarios that can happen. We could also have nothing happen for the next 30 years, and then when it does hit 50 years later, it's going to be even bigger. So these, you almost kind of want it to just get over with, because the more it builds up, the worse it's going to be. And the thing is, based on the strain rates and historic ruptures for the past 1,000 years, seismologists estimate that the strain accumulation on the San Andreas is the highest it's been in 1,000 years. That's a recent research paper that came out using that data, and well, we're locked and loaded in California. So this 7.3, the Venezuela quakes, this notable Gulf quake, never seen an earthquake that big in the Gulf before, right? If you go just by the magnitude, you may lose sight of the full picture. But if you look at, oh, it's a very notable historic quake. We've never seen one that big before. That tells a different story. It gives more significance to it, right? This one isn't necessarily unique in that regard, but extending that higher seismicity wave a little bit further north and occurring before the 7.3. So while it's pretty far afield, that is, showing overall movement here for Mexico, right? We get fault rupture right here, and we get fault rupture there. So yeah, go back to the chat, see if there's any questions. Another super sticker from Seek the Light. Thank you so much. And seriously, Candace, what needs to happen to cause big seismic activity? Is there something that makes progress stagnate? Yeah, I feel like I kind of answered your question just now with what I just said. So as it relates to is there something that makes progress stagnate? I mean, we could look at solar activity, that rhythm that I described, also that 35-year approximately rhythm for California, where you get this peak and then you get this low. So if we get through this peak period, which we're in right now for California, then things are going to be quieter, very much less likely to have big ruptures during the low. So think like 2040, or more like 2030. Like the 2030s are probably not going to have super big activity, but maybe going into 2040. But 2040s, 2050s is probably start to raise back up again. But yeah, I mean, there's a lot of factors here. But the big thing, I'll just reiterate this once again, is that this plate is connected to this plate, which is connected to that plate, which is, this plate's connected to that plate. So when you have a big plate movement here, you are going to have a big plate movement here. It's just a matter of time because these two are directly talking to each other. And if you get this to shift significantly, now you have new strain buildup there. This is plate tectonics 101. That's why we see these sequences occur. And usually often in pretty close succession as well, like right after each other. So now we have very good proof with Venezuela and the 7.3 Mexico, and also if you take in the megaquake in 2017 and Mexico, Alaska up there with its megaquake in 2021, we have very clear proof that we are looking for something here to happen very soon. And I don't think Ridgecrest was enough because that is kind of in the middle of the megaquakes with Mexico and Alaska being 2019, right? Other one being 2017, 2021. It's in the middle of that. So yeah, that maybe speaks to that megaquake sequence, but all this new activity now, I think speaks to a new magnitude 7+ in California. Personally, find out. I hope I'm wrong. I really hope I'm wrong. But we're looking at a data-driven scientific approach here. Something else to mention, let's just touch on this for just a little bit, is we right now have historic planetary geometry. It's actually almost perfectly exact today. Like it's been active for a while, but in terms of them being the most precise, that's I think on the 19th, but basically today, tomorrow, the next day. So we have sextiles between Jupiter, Uranus, Uranus and Neptune and Pluto, okay? Now these are the big gas giants, of course, so these are the most significant parts of this, but 60 degrees there, 60 degrees there, 60 degrees there. Forms this basket configuration, which is very rare. We don't really see things like this. This is like historic on a multi-thousand year time scale, this configuration. Because as a result of these 60-degree angles, you have a Pluto-Jupiter opposition right now. So if you look here, you see this Pluto-Jupiter opposition. If you go to Neptune, you have a Neptune-Jupiter trine. You have a Uranus-Pluto trine. So there's all these internected cycles as a result of this perfect geometry. And we see this connection with seismic activity and planetary geometry. It's not just usually one factor that causes it, like, oh, we had one alignment and now we can expect a big earthquake. It's when you get a convergence of planetary geometry, 5, 6, 7, or 8 aspects, like a lot of aspects that coincide closely in time. That's when we usually see a seismic response. That's also usually when we see a solar activity response. So everything there's this multi-layered 5G chess situation that exists in our solar system, which we're just starting to figure out. But the planetary geometry right now is historic, and I wouldn't be surprised if we get a historic earthquake to occur as well as a result. Just looking for questions that have come in. Not really seen any. We may call it. Here's one. Any indications for Seattle? As of right now, nothing really. We did just have a little swarm that struck Seattle not too long ago, actually. We go up. We may be able to find it. I think it's, here it is. Yeah, so we had a little swarm here, but 3.8 struck and 15 earthquakes total. It's not enough for me to be like really concerned about this area, but it could happen at any moment. All these areas, it's not just California, it's also Oregon, Washington, the Stoch Fault Utah, super overdue. You have many faults across just in general this shear zone. So we're talking Arizona, we're talking Utah, even New Mexico, Colorado. I mean, a lot of people think Colorado is a safe place for no earthquake activity. You'll eventually get a big one there. We've seen across time a lot of big ones strike all across this region. Just look at the satellite imagery, right? It's all nice and calm here, and then the moment you get here, where that great path cut through, right? I mentioned earlier, this is an old subduction zone. It's just torn up. I mean, it's really just chewed up. So you get big activity where there's mountains in general. There's tons of old faults here all across. Yeah. I'm talking also like magnitude 6. Like a 6.5 in some of these areas is pretty big, right? But it can be magnitude 7 or greater. See what else is happening here. Here's a report, a field report for us. I live in Guatemala City and we felt it pretty strong. It keeps shaking by now. Communications are irregular. Cities as Quetzaltenango and San Marcos felt it even stronger. Okay, yeah, these aftershocks are still popping off. As we can tell, newest earthquake here, 5.0, 5.1. I mean, this is a huge amount of magnitude 5s that are popping off right now as a result of the 7.3. So cumulatively, this is coming in still, maximum is bumping up to a 7.4 cumulatively. So it's not like these magnitude 5s, if you add them together and then the magnitude 6, it's not like it bumps it to a 7.7 or something. But this is a very, very clear main shock, aftershock sequence. It is possible that we get something bigger, but I don't think that's likely. Like it's like a less than 5% chance that actually something bigger happens here. But because we had the 8.2 just nearby in 2017, I don't think that we're going to get something bigger than this. I think this is what it is with these aftershocks, but we could get an aftershock that goes up to magnitude 6.5. It's possible. But again, based on the location, while these places are experiencing shaking and more, we hope everything's fine. Everything seems in general capital OKAY. So it could have been much worse in terms of striking location, for example, right under, like, you know, here. I think that's Guatemala City. Like, it could have been much worse in terms of epicenter location. So thank you for reporting on that. And our mod here saying, talk about New Madrid. I mean, I've talked about it so many times now. In addition to California, the fact that New Madrid also, you know, is pretty close by here, I think it is notable because the last time we had New Madrid pop off, it was in 1811, 1812, same year that Venezuela popped off. So we have this connection as well between these two locations there. So thing is that we're not seeing activity around New Madrid that has me concerned. Whereas in California, we had the 5.6 Ukiah Willits. We've had the 4.1, 4.3 on the Garlock, effectively, right? There's some, again, some people are saying Pluto fault, whatever, right on the Garlock fault. We're not seeing activity New Madrid that's saying, okay, pay attention. But if we start to get, like, let's say a magnitude 6 pops off, that's probably a foreshock. It's probably a foreshock. So if we start to get magnitude 4s and 5s, I think, who knows, but I think we will have signs before New Madrid really goes off. I think we'll start to see magnitude 4s and 5s pops off, which will create the initial fractures that then allow for a bigger slip to occur. That's often what we see, is that we do see these foreshock swarms, which then result in the big earthquakes. And New Madrid was multiple earthquakes, multiple magnitude 7s and 6s. I have a graphic here I can pull up for New Madrid. So, and that's how the locals say it. So don't get mad at me. I just go with, because they get mad at me if I don't say New Madrid instead of New Madrid. So just whatever. So yeah, where's this graphic? Maybe this is it right here. Yeah. So this is the seismology the geology of New Madrid, and we see the Rio Foot Rift buried underneath the Mississippi. You also have the Rio Grande Rift buried under the Rio Grande. So interesting that these big rivers have these big rifts buried underneath them. You often see big fault lines underneath rivers. That's, they're connected together. So, but we see that there were big seismic events that occurred in New Madrid, 2350 BC, 1620 BC, 300 AD, 900 AD, 1450 AD, and then 1811, 1812. So the reoccurrence interval on that in general seems to be decreasing. Right now it's like, about 210 years later. So maybe the next big event to hit New Madrid is another 150 years from now. It's certainly possible. It could be 400 years from now. I mean, there's a bit of variability there, but it does seem to be decreasing, at least with this short geologic record. And there were events that occurred all across, multiple magnitude 7s, magnitude 6s, and more. So it's possible that we get New Madrid to pop off. That could be next. I don't think it's the most likely scenario. If it is going to happen, I almost certainly again think that there will be warning foreshocks, magnitude 4s and magnitude 5s that are letting us know, or even magnitude 6s letting us know that it's coming. So if that happens, I'll be right there on it, okay? You have my guarantee on that. Go back to super thanks. I think some new ones have come in, and then we'll sign off here. 121, Corey, when was the last time California got a bad earthquake? That was the 2019 ridge crest. So yeah, that's the last time. Before that, 2010, Mexicali. We're at the border of Mexico and California. But in terms of the last big magnitude 7.5 or greater, that's the Kern County in 1952. So it's been a while since we've had a 7.5 or greater. And there's a big difference between a 7.1 like Ridgecrest in 2019 and a 7.5, or Fort Tejon, San Francisco, respectively 1857 or 1906, 7.9. So it's been a while, but the last big one, like magnitude 7 or greater, Ridgecrest 2019. Thank you for the super thanks. And seriously, have you seen the show Sense 8? Yeah, that's an old show from a while back. That was fun while it lasted. I think they canceled it early though, but that was interesting. Yeah, Amanda, thank you for the super thanks. And Nikki, I don't follow her, and I'll just, I won't really comment beyond that because I don't really have much to say. That's good. But yeah, I don't follow her. Thank you for the super thanks. Megaton Cellular, thank you for the super thanks. And Nikki, once again, thank you so much. Here is the last question that we will do, which is from Skeets. Do volcanoes take the pressure off faults or cause earthquakes? It can be, well, that's interesting. Let's start with the second part. Can they cause earthquakes? Yeah, volcanoes often have big earthquakes that are associated with them. So a good example would be Hawaii, which is having tons of earthquakes all the time because of the hotspot and the volcano. A really good example is 1975 when they had a big magnitude 7+ earthquake that struck, and that's all related to the volcano. So volcanoes, the bigger the volcano, the bigger earthquake it can generate. And they can get really big. And big earthquakes can set off volcanoes. We see that relation. It may take a year or two, but there's a really strong record with some of the biggest volcanic eruptions having really big earthquakes strike nearby just a year, 2, 3 before the huge eruption. So geologically, that's like a blink of the eye. So yes, on the second ones, and do volcanoes take the pressure off faults? That's a bit of a different question, but in general, yes, that is possible. So if we go here to the Juan de Fuca plate, you see that we have these earthquakes along the, and we're not seeing too many because this is a short time frame here, but in general, you don't get too many earthquakes along this section. You get a lot less earthquakes along this section here versus here. Well, right here we have axial volcano. You have a big seamount volcano, and that's taking a lot of this energy and releasing it in a different way. So it's not really a surprise that we have this aseismic gap right there, right where we have this very large submarine shield volcano. So it's not all volcanoes take pressure off faults, but that is kind of one of their mechanisms. So yes to both. And just one last thing, just making sure, looking through. Oh, and we'll finish with this one because this is an important question, and I'm glad that we addressed it now. Another area, maybe actually the area that's most on the firing line. We spent a lot of time talking about California because, I mean, that's where I am. I grew up here, so I have an interest in that, and a lot of people have an interest in that, etc. But huge earthquake coming to Colombia. Any thoughts? Well, look how close Colombia is to these two epicenters, okay? So actually, I would say if anywhere is looking like it's going to have a big quake in the near future, it could be Colombia or maybe Ecuador here. I mean, Colombia, Ecuador, northern Peru, but we get big quakes in Colombia. This would not surprise me at all. So I would also, yeah, there's definitely, if you live in Colombia, I would be prepared and get ready because that could very well have a big magnitude 6+, 7+ in the immediate future. It could happen within weeks or months. I mean, it could happen tomorrow, but it really could happen within weeks or months that we get a big magnitude 6.5+ in Colombia between now the 7.2, 7.5 Venezuela and the 7.3 Mexico with aftershocks. I mean, yeah, this is all right in that area. We may not though. Colombia may avoid a big event in the immediate future, but certainly a big area to watch. So I'm really glad that you brought that up, and I hope it's fine. But yeah, that for sure rounds it out. So again, just to finalize, 7.3 here with multiple aftershocks right at the border of Guatemala and Mexico, the Chiapas region, great coffee coming in from there. Maybe it's because they're getting shaken up all the time. This is right next to the location of the magnitude 8.2 megaquake that occurred September 8th of 2017. And this is following up less than a month after the 7.2 and 7.5 doublet that struck Venezuela, where thousands of lives were lost. Thankfully, it does not seem to be the case here with this earthquake. I'm sure there has been some destruction, some damage, hopefully no injuries or deaths. I don't know. We'll find out with time. I will be releasing updates on this on my X account. So that's x.com/Stefan Burns Geo. It's linked in my video description. I post updates in between videos there. I'll be back with more information on my channel, so make sure you subscribe, smash that thumbs up button to help the channel grow. I release videos almost daily. I also have a pledge to you all that when big things happen, when it's going down, I'm here if possible. The only time I won't be live or something like that is if I'm up flying in an airplane or something like that. So that's the case here. I was live within 90 minutes of this event occurring, reporting for you on this, and I will continue to do so. So whether it's a big solar flare, big solar storm impact, big earthquake, big geo event like a huge volcanic eruption, so long as I'm not being impacted directly, I'll be there for you guys with the best information I can, all the different perspectives and more. So thank you all so much. Wishing all of you well. Please say your prayers for Mexico and everyone that's been impacted by this. And prayers for all the surrounding locations as well, because this is definitely evolving now with this new 7.3. We're seeing tons of energy around the Caribbean Sea Plate. This is now spreading outwards to South America and North America, and well, things could get even more spicy in the weeks and months ahead. So yeah, prayers for everyone. Much love. God bless. I'll see you all in the next video.